Black holes, the mysterious cosmic giants that trap everything, even light. And over the last century, they have been breaking some of the most fundamental rules of physics, many of which have been solved except one. This is the infamous black hole information paradox. What exactly is a black hole? Imagine a star, one much bigger than our sun. Like all stars, they have two forces acting on them. The first is gravity trying to collapse the star inward, and the second is nuclear fusion pushing outward by fusing atoms in its core. But when the star runs out of hydrogen, the fuel it burns for fusion, it loses that balance. At that point, the star collapses. It shrinks smaller and smaller, becoming incredibly dense, until its escape velocity, which is the speed something needs to reach to break free from the pull of gravity, like how fast a rocket has to go to escape the gravity of the Earth. The stronger the gravity, the faster you need to go. Now imagine a massive star. As it collapses, its gravity gets more intense. Eventually, the escape velocity needed to get away from the star becomes faster than the speed of light. And since nothing can move faster than light, nothing can escape. That's when the star turns into a black hole, an object so dense and powerful that it traps everything, even light. The boundary around a black hole is known as the event horizon, where gravity is so strong that it surpasses the speed of light. Anything crossing that line is pulled inside forever. In physics, there is a rule stating that information cannot be destroyed. Everything that happens in the universe, every interaction, particle, or change, leaves a trace. Even if things get messy or chaotic, the information is still there, hidden in the details. Quantum systems evolve according to the Schrödinger equation, which is deterministic and unitary. Unitary means that quantum information is preserved. If you know the state of a system now, you can, in theory, work backward to reconstruct its past. For example, if you burn a book, the pages are gone. The remains are only ashes, heat, and smoke. But according to physics, if you capture every molecule of smoke, every tiny burst of heat, every particle of ash, you could, in principle, reconstruct the entire book again. The information isn't lost, it is just scrambled. So if nothing can escape a black hole, what happens to the information that falls in? That question haunted scientists for decades. Then in the 1970s, Stephen Hawking made a discovery that changed everything. He realized that black holes, in his own words, ain't so black. Because of Heisenberg's uncertainty principle, empty space isn't truly empty. Tiny bursts of energy randomly create virtual particle-antiparticle pairs that pop in and out of existence all the time. Now imagine this happening right at the near edge of a black hole at the event horizon. Sometimes, one of these particles falls into the black hole, while the other escapes into space. And when that happens, the escaping particle becomes real, and we see it as Hawking radiation. To release that particle, the black hole has to give a tiny bit of its energy. So over time, the black hole slowly loses mass. This slow leak of energy adds up, and the black hole starts shrinking, almost like it's evaporating into the cosmos. So if black holes can disappear, what happens to the information that fell in? If the mass goes out as random cold radiation, then the information is gone. But didn't we just say that information can't be destroyed? Isn't it one of the most fundamental rules of physics? This is the paradox. On one side, quantum mechanics says information must be preserved. On the other side, black holes, according to Hawking's discovery, seem to erase it completely. Two of our most trusted theories are locked in a battle, and one of them has to be wrong. If information can be lost, then everything we know about reality, about cause and effect, might collapse. And if it can't be lost, then something about black holes must be wrong. One possible solution suggests that the information never really went inside the black hole. What if it was somehow stored on the surface, on the event horizon itself, a kind of a cosmic hologram? And when the black hole evaporates, the information leaks out with the radiation in a way we just don't fully understand. It sounds ridiculous, but it might be true. This is called the holographic principle. It implies that reality is merely a 2D illusion. We might create a full video on this, so stick around to see the latest updates. And if you are still certain that the universe is 13.8 billion years old, check out this video to find out why this number might be wrong.